Welcome back, everybody.
Hello, hello, hello. Welcome, everyone. Welcome back to Getting That Medical Degree. And today we're going to talk about another Mcat series episode. What are we going to talk about?
So we're doing the immune system today. We'll actually be finishing up all the biology session in the next couple of videos, so that'd be cool, I guess. So let's get started with the immune system. So the immune system's structure is you have innate immunity and an adaptive immunity. So innate's basically mean like immunity you're basically born with. This is stuff that's always active, but it's not specific to like the bacteria or virus that's infecting you. So with this, think about your skin, the mucus in your nose, your stomach acid, your tears, sweat, stuff that's going to happen anyways, and it's there. It just doesn't really matter like what bacteria it is. It's still going to affect it a little bit. And then adapt is more of like a slower response. It's like takes time to activate, but it's more specific to the invader. So think COVID, for example. If you got a COVID shot, that makes you have like memory T, memory B cells, and then you get COVID. That's more of an adaptive response because now your body's like, oh, we know how to fight this. So go on from there. They have non-cellular innate. So innate has different parts. It has cellular and non-cellular. So we'll get both of those. First, the non-cellular, the skin. So this is your skin. It protects your inside organs. It also secretes enzymes that are antimicrobial. So like you get dirty or something, you're not worried about getting infected because you didn't touch like your eye or something. That skin's protecting you from getting sick for that antimicrobial enzymes. Like nothing's really getting through unless you have a cut. Mucus, like your nose and stuff, this traps pathogens so they can be removed by different mechanisms. Lysozymes is you're located in your tears and saliva, so it's basically an antimicrobial compound that kills microbes, basically antimicrobial. So when you get something in your eyes start tearing up because trying to get whatever's out from your eye from using those tears. The complement system is going to like punch holes in the cell walls, and bacteria. So of course, when the cell walls have holes in them, that destroys the structural integrity of the cell wall, which makes them unstable. And then this leads to lysis, and like your cells can help a fight. Then they can get in and go hi and destroy them. Also interferons. So if a cell gets infected, it will give off like these interferons, and that interferes with viral replication and dispersion of the, I guess you could say, like the badness or the sickness of the cell. Again, stuff can always mutate, like bacteria can mutate, viruses can mutate, and kind of can get around the system some way. But this is just the general way how the system works. Then you have the cellular innate. So this is like what's going to happen in the body before like your body really knows what's going on. This is just the normal way they do things. So macrophages are like Pac-Man. They basically just eat pathogens, and they secrete cytokines, which basically eat the pathogens, secrete cytokines, which causes more cells to come into the attack. Then you have MHC1 and MHC2. The Mcat likes asking questions about these. So like MHC1's on all nucleated cells, and this displays like an endogenous antigen to the cytotoxic CD8 CT cells, while MHC2 is displays it to the helper T cells, CD4 cells or T cells. These are more on like the specialized cells, so macrophages, dendritic cells, some B cells, and some epithelial cells. The dendritic cells present the antigen on the skin, so these are the antigen presenting skin cells in the skin. And NKC is natural killer cells. They basically just attack cells.
Those are my favorite kind of cells.
They just go eat them, attack.
Yep.
Looks bad. Let's get them. That's basically what they do. Then you have a granulocyte. So the easy way to memorize these is Ben. So BEN. That's why we're going to work from the bottom up. So basophils are activated by allergens. They also inhibit blood clotting. You have eosinophils, which are activated by parasites and also allergies, and they release like histamine. So histamine is kind of what causes like your allergy symptoms, like your runny nose, your sneezing. That's from histamine. And then neutrophils are activated by bacteria, and they basically eat stuff. They go phagocytosis, which means just eating. Adaptive, so again, humoral and cell mediated. Humoral is more like antibody production by B cells, and they kill antigens while they're floating around. Cell mediated is like centers on the T cells. It kind of responds to cells once they've been infected by an antigen. So the humoral is the B cells. They are made and mature in the bone marrow. They are activated by the spleen or lymph nodes, and they express antibodies on their surfaces. Basically, the antibody, the tip of the variable region, is the antigen binding area on the antibody, so that's kind of important to know, the tip of the variable region. And a hypermutation can occur, and that's a mutation on the antigen binding site on the antibody. Opsonization is basically where antibodies mark pathogens for destruction, like, hey, that's a bad guy. Let's mark him so the body remembers what to attack. It's pretty cool. And then you have agglutination. I probably completely butchered that word. But basically where pathogens are clumped together into like something that cannot like insoluble clump of cells basically, and then that's caused by the opsonization of pathogens, so kind of adds on to it. And then you have memory B cells. These wait for the second exposure to the pathogen, so it kind of gets into like immunizations where you get given a shot, introduce your body to the cell, and then they make memory B and T cells. Cytotoxic immunity, so T cells are made in the bone marrow and they mature in the thymus. So going back to the other side, B cells are made and mature in the bone marrow, while T cells are made in the bone marrow but mature in the thymus. This is a small detail where the Mcat might ask you like a discrete question on to see if you can figure out what the difference is.
A sneaky question.
Sneaky, yeah. Or they may put in like a discrete section where they make to compare and contrast these two cells, and the only difference is one matures in the thymus. You also have helper T cells. These are also called CD4 cells. Again, the MCAT's probably not going to say helper T or cytotoxic T. They're going to say CD8, CTL, or CD4, just because that's more confusing if you don't know what that means. Like helper T says, oh, this helps activate the immune system. If they say CD4, if you don't know that's actually helper T cells, you'd be like, oh, this is a weird cell. I don't know what this does. It doesn't really help you. It doesn't give you context clues on what it does. But again, these respond to antigens presented on the MHC2s. And they secrete lymphokines, which activates the immune response, which is why they're called helper cells. So they're kind of recruiting more cells to the site. And cytotoxic, or CTL or CD8 cells, they respond to antigens presented on MHC1, and they kill infected cells. Okay, that's all good and dandy, but what happens after the infection is taken care of? So that's where the suppressor T cells come in, and they basically tell the immune system to like, hey, we solved the problem, calm down. And memory T cells, similar to B cells, they just wait for the second explosion to come back. Exposure to come back, not explosion. Cytotoxic immunity, so this is autoimmune. So autoimmune basically is help antigens recognize as foreign and the body attacks it. So which is not good. You have allergic reaction, so it can be like a site from a maybe you're allergic to like latex or something, and you get like a rash, but you can also have like anaphylactic shock as well. So that's something to keep in mind. And passive immunity is also transfer of antibodies. So like breast milk, for example, is an example of transfer of antibodies if the mom just got like a shot. So in the lymphatic system, so this is like a provides a mounting immune response. It's connected to the cardiovascular system. It transports fats and fat-soluble compounds. It also like helps with fluid regulation. So if the system goes down, edema or fluid might build up, called edema, which is not good. So a couple questions for you guys. So the first question is, what granulocyte is involved with parasites? So thinking back, what is a granulocyte? That's your Ben. And the answer to this is eosinophils. That's involved with parasites. Why might edema occur? I just talked about it. So like your lymphatic system is involved with like fluid regulation. So lymphatic system's why edema might occur if you have an issue with that for some odd reason. And then what type of a cell is a CD8 cell, and what does it do? So as I said before, a CD8 cell is a T cell, and that responds to antigens presented on MHC1. So that's it for this, guys. I hope you guys learned something. Anything to add, Mitchell?
Hope you guys come back and review.
Yeah. Thanks for listening.
Thank you guys for tuning in.
Peace.